Hello, Don Reeder again here with Greg behind the camera. We're going to do a couple of new videos. The first one is going to be on precision grinding wheels, primarily for the surface grinder. You could use them in other ways, but we're talking about getting these wheels really close to eliminate, or pretty much eliminate, a problem that throughout the years I've just accepted as a shortcoming of a belt surface grinder. For years, back in the 1960s and 70s, I know I'm older than dirt, but that's when I first started working on these and rebuilding this type of equipment. Didn't look like this, but we used to use them for finishing panels, wood panels, steel panels, aluminum, about any material. And it was a large table with a 200-inch belt that was about 6 or 8 inches wide. And the belt would go round and round, and the table would go back and forth, and in some cases laterally too. What we would do is we'd put our hands in between, in that belt, which came around. You'd take a rag and you'd fold it up and you'd put it on the belt, and you use your hand to push on the back side of the belt to surface finish a panel, and you move the panel back and forth, in and out, and when you did it with a rag, all things worked out pretty well. Well, they come out with a kind of an automated version of that, and the modification of that was we put a big wheel like this, only wider, in the middle of the belt, and you could push that up and down while the panel was going back and forth and in and out. Now, when we put this type of wheel in, that's when we got what we called sanding tracks. And those were, it was accepted those were coming from the inaccuracies of the machine and the belt splice. Now, when you did that, we'd take a bunch of panels and we'd rough them with this type of setup, and then we'd change over, usually to a finer belt, and you go to the rag in the middle of the belt and you push down on it back and forth, and you'd eliminate that, what we call tracks from now on. Well, Josh with REK Knives called me up and he said, you know, I think you're wrong. I think the tracks you're experiencing are really not coming from the splice. They're coming from eccentricity of the contact wheel. Well, I knew that was true, but I didn't think that was actually the primary cause of it. However, he sent me a picture. He had a machine shop grind or turn an aluminum wheel that was, he said, perfectly concentric. Nothing's perfect, but real close. And he showed me the picture of the knife, or the picture of the finish on it, and it was really good. It was better than what I was getting. So we went back and had a hard look at it and realized that what we needed is, if the concentricity of the belt, the 4-inch, or the wheel, the 4-inch wheel or larger, whatever you're using on your surface grinder, was almost perfect in concentricity and parallelism, that we got a greatly improved finish, a finish that I really didn't think was possible with a belt surface grinder. That's the long story short. Now let me show you how our machine works and what we're going to be able to. And one other thing, if you bought a machine from us, what was it, before August 15th, Greg? A machine from us before August 15th, and there are a lot of them out there, surface grinder, with the 4-inch wheel. And so you bought the 4-inch wheel that's 2 inches, 200 thousandths wide, 90 durometer wheel. If you bought that from us before August 15th, you need to send that back to us if you want, and we will precision grind that wheel and won't charge you for it. And we're going to show you how we do that with one of the guys that already found out about that, sent his wheel back into us to do that. We're not going to charge you for that because we realize now it's something probably we should have been doing from the very beginning, just didn't realize it. So that being said, this is the device that I've built specifically for surface grinding wheels and getting them extremely parallel with the axis of the wheel and concentric. So I'm going to show you that process, and I'm going to explain a little bit. This setup is a wheel that we've machined and hand finished so that we've got this wheel well within 1,000 side to side and parallel to the axis and concentric within one. So then this, what we do is we have a angular adjustment so we can rock this back and forth so that we can make this shaft parallel to that wheel. And then we have a testing fixture this is out about 5 thousandths. Now let me tighten my finish wheel up here. 0, 2, 5. Or what that means is this surface is this part of the wheel is pushing this indicator in 5 thousandths more on this than it is on this. That's wrong. This is going in 5 thousandths further than this is. So that means this is skewed this way, which means we have to rock this back. Now, we're not going to show you this every last adjustment because this takes a little while to get the machine set up, and this tells me how far I'm moving that. So what I've got is this is rocked. I'm just going to double check it because I've forgotten here. This is shallow, this is deep. That means this is rocked this way. So we've got to push it that way. That means we've got to turn this in, and I'm going to move it in about 10 thousandths here, and I'm going to go back and double check this now. Okay, that's down to about 3 thousandths out. So I'm going to go a little more. Loosen these up a little bit. And I'm going to take that 5 more. All right. All right, let's have another look at it. I'm going to re-zero this now. Okay, that's within 1. I can dance back and forth on this, but when you get it within 1, since I'm traversing back and forth, that gives me a really accurate wheel side to side. In other words, the wheel is not sloped across it, it's not tilted. All right, we've got that done. Now we're going to lock this up. It's on 0, so I'm going to tighten this up. Okay, now we'll double check it after I tighten it. Okay, now we're going to put, I don't know whose wheel this is. Do you know, Greg? Okay. Okay, I've got the machine set up. I believe that's an 80 grit belt I'm working with right there. And now I'm going to feed this in till I get just a touch. I'm going to zero this. Spin, all right. Now I'm going to feed this in. I'm going to re-zero that. Greg's going to edit some of this out to shorten this video up, but this wheel, I checked it before we started. It was out about 7,000. I've tried turning these, freezing them, doing a lot of different things to them, and sanding them with this piece of equipment seems to be the best thing, the best way to go. Now, I like to do this by hand instead of with the crank when I'm doing the finish operation, because I can feel it. I can feel that I'm not exerting any pressure and loading that wheel up. I can also feel the resistance on the wheel, and I know whether I'm taking a cut or whether I'm free, I'm cutting free. I reverse the wheel just so that if I do have any out of round or out of parallelism, that when I can feel it. I can feel whether the wheel is loading. I felt no load on it when I came across it. So I'm going to go back now to the other side. And now I'm feeling virtually no load on it. Now, we can do this for any wheel all the way up to 14 inches. It takes a long time to do a 14-inch wheel. So now we'll cut that off, and now we're going to go over and double check this and see where we are. Okay. Now I know I wasn't doing much talking, I was doing more thinking and I rarely think, so I can't talk and think at the same time. So now we have a wheel that we've done in it's precision ground. What we're going to do now is we're going, and we can do this all the way up to a 14-inch wheel. We're going to do a video on surface grinding and show the type of finish we can get with it. I've got a sample over here that I've already done, but in the next video we're going to show you from start to finish how we get this. Can you see that? I'll try and bounce the light off it. See if you can get the camera. I'm going to move it back and forth like that and up and down. Can you see any track or any movement in that? All right, now this was done with a 600 grit belt. Let me flip it over. Now come over and I'm going to mic it and I'll show them what we're getting on that. This far exceeds what I thought was even possible with this type of surface grinder. It's 149.8. $150 and a couple of tenths. $150. Now let's turn around, see how we're parallel here. $150 and about 5 tenths. $150 and 8 tenths. That's a little, it's down to 144 and a half. So what it boils down to is the majority of this is flat and parallel within, well, I won't say flat. It's parallel within a thousandths over most of it. At this very end, it's out just a little bit. Now, as far as flatness goes, when you do just the rock test on it, it doesn't rock and it doesn't move up and down. We could check that on the surface plate. We've got one at the shop. I don't have one here, but that's good and flat and really good and parallel. On the next video, we're going to show you how we do that. Okay, again, I want to again thank Josh Francine with REK Knives for bringing this to our attention. We've dramatically improved the quality of what people can get with our surface grinder, primarily thanks to his disputing what I thought to be an accurate assessment of what the machine's capable of. You know, we've gotten comments and suggestions from a lot of our customers throughout the years, and they've helped us in many cases improve things or develop new products. And I just really want to thank people for doing that and keep them coming, because you guys use this equipment far more than I do. I move on and design something new, and you guys sit there and work with it day in, day out, and a lot of times your observations about the function of any of our products are more valid than our own, just simply because you've got more experience with the equipment. So we really appreciate it, and anything that you've got, contact us and let us know your thoughts. Sometimes we can't do anything with it because the cost of changing something is prohibitive, manufacturing costs being what they are. We just can't do it, but a lot of times we can make small changes that make a big difference. Now we're going to show you, Greg, go ahead and get down on this, look in the viewfinder. We're going to show you what the tracks were like. Get right down on top of it. There you go, you can see it in the view. There's little tracks there along the handle of that knife. Now move over to the next one. Probably you can see it a little better here. Yeah, right there. Those are the tracks we're talking about. Now those tracks are only, you know, a tenth or two deep, but they're still there. Here's the piece that we just did. We said we did that with a 600 grit belt. We didn't. We did that with a 240 belt. No, yeah, that's right, a 240 belt. So now in the next video we're going to show you how we use the surface grinder now and how you can get the really phenomenal finish out of it. Again, thanks to Josh, far better than I ever expected we could get with this type of machine. Okay, thank you a lot.